Okay, so our next section we are looking at is 4.5 on maximum and minimum problems, which is a popular concept in calculus. And it's going to relate back to 4.2 when we were talking about our quadratics and we were talking about vertex form for our quadratics. And recall our vertex form was the f of x is equal to a x minus h quantity squared plus k. And we know that when a was a positive number, our parabola was opening upwards, where our vertex, hk, is the lowest point on our graph, which would make sense if we're talking about minimums. And if a was less than 0, that meant that our parabola is opening downwards, and that hk point is going to end up being the highest point on our graph, which would make sense if we are talking about a maximum. So as we do these problems, and anytime you're hearing the word maximum, minimum, smallest, largest, you want to be thinking of our quadratics and that vertex specifically, because the information about that largest or highest or maximum or minimum is going to come from that vertex point. So if we look back to our general form of our quadratic in standard form, which was the ax squared plus bx plus c, and on the last problem in 4.2 on our notes, we took that general quadratic in standard form and we switched it to vertex form, and we ended up getting the equation a x plus b over 2a quantity squared plus 4ac minus b squared over 4a. And we know that the vertex of that parabola is the negative b over 2a, comma 4ac minus b squared over 4a. That is our hk, our vertex there. And depending on if a is positive, where then we know that our vertex, our graph is going to be opening up, so our vertex is going to be a max again, or if a is negative, where our vertex is going to be that lowest point, which would make sense that we're talking about a min. This is what we want to be focusing on, okay, is that vertex. And very specifically, the easiest thing that we want to be looking at is just this minus b over 2a. That is going to be the easiest thing for us to remember, is the x of our vertex, because if we have an x of a point, we can always plug it back in to get the corresponding y value. So a big time saver with our word problems is just remembering that the x of your vertex is always this minus b over 2a. Now, in terms of going through strategy for solving those word problems, I'll let you kind of read through that, but just to quickly just generalize or to kind of go through very quickly is anytime you're doing a word problem, you want to be very careful about just reading it accurately and making sure that you're picking up all of the important information and specifically what it is that you're being asked to find. And as we do these max-min questions, you're going to be asked to either find something about a maximum or minimum, but you're going to give constraints. Constraints meaning I have so much fencing and I need to determine the maximum area. So my constraint is the specific amount of fencing that I'm allowed to work with. And we're going to use all of that information in order to form an equation that we can then solve for our maximum or minimum or whatever it is that we need to be solving for. So let's actually go through some examples, and I think will make a lot more sense. So let's look at number 1. On number 1, we are given two numbers that sum to 5, and we want to find the largest possible value of their product. So again, as soon as you hear largest, smallest, maximum, minimum, you want to be thinking of your vertex with your quadratics. That is kind of a clue of that vertex information. So like any word problem, we need to define the variable that we're working with. So we have two numbers. I'm going to define my first number as x, and I'm going to define my second number as y. And if my two numbers sum to 5, that means that x plus y would need to equal 5. And if I want to know the largest possible value of their product, well, in order to get a product, that means that I would have to multiply those two numbers And to get my, sorry about that. So if I multiply those two numbers in order to get my product. Well, we don't want to be working with two different variables. We want to be working with one variable. So this is our constraint that our two numbers have to add up to 5. So I can use that constraint to solve for one variable in terms of the other. And I want to work with x's, so I'm going to solve for y in terms of x, and I'm going to let y equals 5 minus x. So now instead of x times y, I could think of my product equation as x times 5 minus x equaling my product. So I'm going to write my equation as p of x, p being product, is equal to x times 5 minus x. And if I go through and I multiply that, I get a 5x minus x squared. If I just rearrange the terms, putting them in descending order, that's going to be a negative x squared plus 5x. So if we look at this equation that we just wrote, p of x equaling a negative x squared plus 5x, it should hopefully make sense that we were looking for largest and our a term is negative. And we know if the a term is negative, that is telling us that our graph is going to be opening, our parabola is going to be opening downward. So our vertex is going to be the highest point on our graph. So it should make sense that we're talking about a maximum, a largest possible quantity. So we know that that highest point on our graph is going to be that vertex point, whatever that HK is. So if we just kind of look at all the points or how we would describe the points on our graph, on every graph you have an XY point, but we want to be a little more specific. So instead of XY's, I didn't use the variable Y on this equation right here that we're talking about. I used X and P of X. And in words, what are our X's? Well, our X, if we go back over here, our X was our first number. So we plug in a number, we get out a P of X. Well, what does P of X stand for? P of X stands for our product. So all of the points on our graph, you plug in a number, you get out a product. You plug in a different number, you're going to get out a different product. So every time we plug in a number, we're getting out a product. Well, HK is just another point on our graph. It just happens to be the highest point on our graph. It's the vertex point on our graph. So if we want to know something about the number, then we should be looking at H. If we want to know something about the product, then we should be looking at K. And we want to know what the largest possible product is. So since we want to know the largest possible product, we need to find K. That's what we need to solve for. Well, the easiest way to find K is to first go through and find the X of our vertex. And the X of our vertex, we know, is equal to the minus B over 2A. So in this case, our X is equal, our B was, what was our B? Our B is our 5, so a minus 5. And our A is a negative 1, and we get 5 halves. And if our X is 5 halves, we can go back and we can solve for our Y value. We can find our second number if we come back over here. Oops. And so our Y is equal to 5 minus X, or 5 minus 5 halves, and we get 5 halves. So that means that our product is 5 halves times 5 halves, or 25 fourths. And that is our max product. Is that 25 fourths. We could have also taken our 5 halves, and we could have taken that 5 halves right here, and we could have plugged it in to our product equation. And that also would have given us 25 fourths. So you had options. It's always nice to have options. So let's look at number 2. So on number 2, among all of the rectangles having a perimeter of 10, we're trying to find dimensions of the one with the largest area. So again, as soon as you hear largest, smallest, maximum, minimum. You want to be thinking of your vertex of your quadratics. So we are given a constraint. We are given a rectangle. And with that rectangle, we have a perimeter of 10. Well, we know with perimeter, we've got 2 widths, we've got 2 lengths. So we know that 2 widths plus 2 lengths would equal our 10, or if we divide by 2, width plus length would equal 5. And we're trying to find dimensions of one with the largest area. Well, if we're trying to find area of our rectangle, we know area of a rectangle is equal to length times width. But we don't want to have 2 different variables, so we're going to use our constraint equation to solve for one variable in terms of the other. So I'm just going to solve for my width in terms of my length. So my width is equal to 5 minus my length. And so my area is equal to L, length, times 5 minus length. So instead of area equals, I'm just going to write A for area, and I was using the L variable for my length, so I'm writing an A of L equation, which is equal to length times 5 minus length, which is 5L minus L squared. And if we just rearrange the terms, it's a negative L squared minus 5L. And again, this should make sense for our equation, or our equation makes sense for the question being asked. We were asked for the largest area, and our A term is negative, which means our parabola is opening downward. That means our vertex is the highest point on our graph. So it makes sense that we're being asked about the largest, about a maximum, because we're able to find that specific information according to our equation. So every point on our graph, you plug in an X, you get out a Y. In this case, we plugged in L's, and we're getting out A of L's. Or in words, we plug in a length, we are getting out an area. And HK is just another XY point on our graph. It's just a special XY point on our graph. It happens to be the highest XY point on our graph. So if we want to know something about length, then we should be looking at our H. And if we want to know something about area, then we should be looking at K, because K is representing area and H is representing length according to our equation. Well, we're trying to find dimensions. So if we're trying to find dimensions, then we should be solving for our length. And our length, or our H, which is the X of our vertex, we know the X of our vertex is equal to minus B over 2A. So in this case, our B value was a negative 5, and our A value was a negative 1. And I screwed that up. Sorry, that should be a plus. That did not make sense because we can't have a negative length. Sorry about that. And so we have our X is equal to 5 halves. And that is our length. And in order to find our width, we can come back over here to where we defined our width. And so then our width is going to be 5 minus 5 halves, which is 5 halves. And that is our width. And that's what we wanted to find. If we wanted to know our area, then we could multiply our width and our length together. But we just needed to know our dimensions. Okay, so let's look at number 3. I'm going to let you do number 3, but let's just draw a little picture just to make sure that we all have it set up correctly. So we have 500 feet of fencing to be used for a rectangular playground along the side of a school gym. So I'm going to have my gym over here, and I have 500 feet of fencing. So these sides are fencing, and this one side is fencing. And you're supposed to be finding the dimensions that will give you the maximum area. So I'm going to let you work on that, and then we will